This video is going to focus on an introduction to macromolecules and talk about how they're made, how they're broken down, and then we're also going to have a quick conversation on carbohydrates, which is one of the 4 types of macromolecules. The remaining videos for this chapter will then focus on the other types of macromolecules. So with biology, these crazy words like macromolecule, if you break them down, it actually gives you their definition. So macro means big, and we know what a molecule is at this point. So these are big molecules. Now they're going to be big in size, but also they're essential for life, okay? So these 4 macromolecules are carbohydrates, proteins, nucleic acids, and lipids. So again, I said a macromolecule is large. Well, it's large because it's made up of a bunch of smaller pieces. We call these smaller pieces a monomer, because what does mono mean? It just means one. It's one individual unit. But we can take this one individual unit and link it to another small unit. We can link it to another monomer, link it to another monomer, and eventually we have what's called a polymer. Now, poly means many. So think about it. We have these small individual pieces. So one piece is called a monomer. And when we link a lot of monomers together, we're going to have many monomers. Well, many means poly. Okay? So really, a polymer is made up of individual monomers. A good example is a train. Okay? Think about what a train looks like, right? A train is made up of a bunch of individual cars, right, that are linked together. So in this case, the monomer is an individual train car, okay? But only when all of those individual train cars are linked together do we have the train, which is the polymer, okay? So a train is made up of many individual monomers, or train cars. All right, well, now how do we make these polymers? Well, what's going to happen is a bond is going to form between the 2 monomers, okay? And in doing so, we're going to lose a water molecule, okay? So we're going to call these types of reactions that are making macromolecules dehydration synthesis. Now, how can you remember this? Well, synthesis means to build or to make. Dehydration, D means loss of, hydration means water. So we are going to lose water to build our macromolecule, okay? So what does that mean for our monomers? Well, what you're going to notice is that our monomers, our individual pieces, are going to have lots of carbons, hydrogens, and oxygens. Now, there are going to be some other elements too, but remember, the first video of this chapter, we said that those are some of the most common elements. So you're always going to find hydrogens and oxygens around, because between the 2 monomers, they're going to have to give up 2 H's and an O, aka water. So what I want you to look at is, notice that this monomer, on the right-hand side, it has an OH, which is called a hydroxyl group, and on the left it has a hydrogen. When I look at this second monomer, it also has a hydroxyl group on the left and a hydrogen on the right. So do we agree that if we want to attach these 2 monomers together, this left-hand monomer, it can lose its hydroxyl, and this right-hand monomer can lose its hydrogen, right? So together we're losing H2O, and that's exactly what happens. So between the 2 monomers, they're going to lose a water molecule, and that's going to form a bond between them, okay? This is how we get some of our energy reserves, right? If we skip a meal, we may get hangry, but it's going to take quite a bit for us to faint, right, or get ill. That's because we have these reserves. We have sugars in our body that have hundreds and hundreds of little individual sugars just all linked together. So then as we need them, we can break off individual sugars and our body can metabolize it, and we can extract the energy from it. So what happens if we have these big energy reserves, but we need to break some of those little monomers off so that we can get the energy from it? Well, we're going to do a reaction called hydrolysis. So the hydrolysis is going to break down the polymer. So again, always use the words to figure out what they mean. Lysis means to break. Hydro means water. So this really translates into using water to break something down. That's exactly what's going to happen. So notice, here's our little polymer, okay, that we had just made. Remember, originally, this guy lost an OH, and this guy lost a hydrogen. Well, if we're going to break this bond, we have to recreate what we started with. So that means water is going to come in and break this bond, and looky what happens. This monomer got his OH back, and this other monomer got his hydrogen back. We have to restore what we originally changed, okay? So one more time from the top, dehydration synthesis, we are going to lose a water molecule as we build our polymer. So this monomer lost an OH, and this monomer lost a hydrogen to form a bond. So therefore, when we break this bond, we need to give this monomer his OH back, and we got to give the other monomer his hydrogen back. And that's exactly what happens in a hydrolysis reaction. We're using water to break down the polymer. Make sure you know the difference between these two and the gist of what's happening. All right, so our first group of macromolecules are carbohydrates. They're also known as sugars, or the Latin word for sugar is saccharide, okay? So we can use those terms interchangeably. So carbohydrates are really unique in their structure. They only have carbons, hydrogens, and oxygens, okay? Now I know there's a lot of text and a lot of pictures on this slide, but you're going to need to be taking some notes as well, okay? So something you want to write down is that carbohydrates have a specific formula, okay? They only have carbons, hydrogens, and oxygens, but they're also present in a specific ratio, and that is an N to 2N to N ratio. You might be thinking, what on earth does that mean? That means for every one carbon, there's 2 hydrogens and 1 oxygen. So look at the example up there. Glucose has C6H12O6. So notice there's always the same number of carbons as there are oxygens, because it's a 1-to-1. So 6 carbons, 6 oxygens. But there's always double the number of hydrogens, or 2N. So if we have 6 carbons, we need to have 12 hydrogens. Okay? So it's an N to N ratio. Okay, make sure you jot that down. All right. So the monomer of a carbohydrate is called a monosaccharide. And those monosaccharides, like glucose here, okay, fructose is another monosaccharide, they're going to link together to form a polysaccharide. Because remember, even though we only show you 2 in this upper picture, look at this. This is an example of cellulose, which is a starch. I'm sorry, cellulose is a carbohydrate. Look how many sugars are in cellulose. Okay, and this is just a small portion of the leaf. Okay, there's hundreds, if not thousands, of these little sugars linked together. Okay, so again, polysaccharide means there's many individual sugars. So again, the monomer is the monosaccharide, the polymer is the polysaccharide. All right, what else do you need to know about your carbohydrates? Okay, you always want to know their monomer and their polymer. You also want to know the name of the link or bond that forms between them. We call this a glycosidic linkage. Glycosidic linkage. Okay? Another fun fact you want to keep in mind is that when you look at the name of something, OSE, that lets you know it's a sugar, okay, or a carbohydrate. Glucose, fructose, sucrose, okay? This OSE ending lets you know that it's a sugar. What do we use carbohydrates for? Well, a lot of times it's for energy storage, okay? But it's also for structure. The cell wall of plants is made up of cellulose, and this is what allows them to survive in really windy and rainy and harsh environments. is the strength of all of these sugars linked together. Okay, so also you always want to know the function of something, so structure and energy storage. All right, the next video is going to be all about proteins.